great day, Math Lead learners! Welcome to Mathematics Lead channel, where we turn your math worry into mastery. I am Hazel, and together, let us have fun while learning. Before we start, let me ask you a question. Have you ever wondered how mathematics helps us solving real-life problems, such as finding the dimension of a garden or calculating the areas and costs? In today's lesson, we will learn how to solve problems involving polynomials and polynomial equation. Without further ado, let us have our learning objectives for today. At the end of the lesson, you, my students, should be able to first, solve polynomial equations using appropriate methods. And second, solve real-life problems involving polynomials and polynomial equation. Now, let us move on to the engaging activity of this video. Some students think polynomials are easy until these statements appear. Today, let's test your understanding in myth or fact. Polynomials addition. Pause the video, think carefully, and let's see if you can beat the myths. Let us have statement number 1. Statement number 1 says that all expressions with variables are polynomials. Let us see. Is it a fact or a myth? Now let's reveal the answer. The answer is, it's a myth because not all expressions with variables are polynomials. Let us have an example. 1 over x plus 2 is not a polynomial because it is what? The variable in the denominator violates its instruction. Next, the second one is the square root of x plus 3. It is not a polynomial because of the fractional exponent. If we are going to get the exponent of x, it would be x raised to 1/2. And lastly, we have 3x squared minus 5x plus 1. It's a polynomial. Very good. Alright, let's have our next statement. Our statement number 2 says that the degree of a polynomial is at the highest exponent of the variable. Is it a fact or a myth? Pause the video and think carefully. Alright, that is a fact because not all expressions with variables are polynomials. Alright, for our third one. 0 is a polynomial. Is it a fact or a myth? Think carefully. Alright, so it is a fact because it has no degree, but it is still classified as a polynomial. Now, for our statement number 4, polynomial can have a negative exponent. Now, is it a fact or a myth? Think carefully. Alright, so that is a myth because negative exponents violate the definition of polynomials. According to our definition, that a polynomial is a mathematical expression consisting of indeterminates and coefficients that involve only the operations of addition, subtraction, multiplication, and exponentiation to non-negative integer powers and has a finite number of terms. So, Math Lead learners, that's the end of our engaging activity. How many items you got it correctly? Alright, that's a very, very good job. Now, I will give you a 2 claps. 1, 2. Great job. Let us move on to the most exciting part of this lesson, which is activating your knowledge. Before we start, let us first recall some of the terminologies that you have knew from the past lesson. The first one is a polynomial, which is defined as an expression made up of variables, coefficients, and exponents that are whole numbers. Let us have an example for this. We have here x squared plus 3x plus 2 and 4x cubed minus x. So, what about you? What are the polynomials that you have in mind? Okay? Next, a polynomial function, which is denoted by p of x or f of x, and it is defined by f of x equals a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus more terms in between until we reach a sub 2x and a sub 1 and finally a sub 0. All that
A's are real numbers. The leading coefficient, A sub n, is not 0, and n is a positive whole number. Okay, so this might be complex for you, but don't worry about memorizing this. What's important is the pattern of decreasing powers of x. Okay? Alright, let's move on.
So you see, a polynomial function are actually being used in fields other than mathematics, such as designing, manufacturing, business, economics, demographics, and so much more.
So you mentioned that there are other ways we could really apply polynomials in different fields. Now we're going to discuss the real-life application of polynomials. And for us to really have the system in order to answer the problems correctly, we have George Polya's four-step problem solving method. So the first step that we have here is understand the problem. Okay, so in understanding the problem, it's not an interrogative style, but it is in declarative style, wherein we're going to have a sense of understanding on what the problem means to you. Okay, that's the first step that you're gonna do, because you cannot answer a problem without you understanding it. That's why that's the first step that we're gonna do. Next, devise a plan. So in devising a plan, you're going to strategize. How would you answer this? What are the mathematical sentence? What operation to be used? And what should you do to answer the problem? Next is carrying out the plan. Now, from strategizing, you're now going to implement the plan that you have in the second step. So here, you're going to answer the problem. It's getting or arriving to the answer. Okay? Then lastly, we have look back. So from here, you're going to make sense on what the answer is. So you're going to look back. Is it really suitable to the problem, or does it make sense on what is the problem being asked to you? So that is looking back. So making sense and also working backwards in order for you to arrive at the same given that is being given into the problem. So that's it, the look back. So we have here the fourth step, understand the problem, devise a plan, carrying out the plan, and looking back. Of our first problem. So here we suppose a windmill generates power based on the speed of the wind. This is represented by the polynomial function P of S is equal to S raised to 4 over 500, where S represents the speed of the wind in kilometers per hour. If the wind speed is 10 kilometers per hour, how many minutes of power P of S can the windmill generate? Okay? So now we're going to understand the problem first, because it's our first step. So in understanding the problem, we are given a polynomial function that represents the power generated by a windmill. And we are asked to find the power output when the wind speed is 10 kilometers per hour. Now, after we understood the problem, now we're going to devise a plan. And in devising a plan, we knew that if we solve a problem, or to solve this problem, we will substitute the given value of s into the polynomial function and then simplify.
Now we're going to move on to carrying out the plan. We have here a while ago the formula, which is the P of S is equal to S raised 4 over 500. Now we're going to substitute the value of S, which is 10. So as mentioned a while ago, the value of the speed is 10 kilometers. That's why we have 10 here. Now, we have P of 10 is equal to 10 raised to 4 over 500. Now, we're going to evaluate 10 raised to 4, which is 10,000. And then after that, we're going to have P of 10 is equal to 10,000, which is the value of 10 raised to 4, over 500. And evaluating that, or dividing 10,000 divided by 500, we have, yes, that's correct. That is 20.
On in checking our answer if they are correct. So we start from our result, which is P of S equals to 20. And then we use the original formula, which is S raised to 4 over 500 equals 20. And then we multiply both sides by 500. And multiplying S raised to 4 over 500, the 500 will be cancelled. And then S raised to 4 remains the same. Now, on the other side, we have 20 times 500, which is equal to 10,000. And then after that, we're going to take the fourth root. In S raised to 4, the fourth root will be cancelled. And then,
the square root of 10,000 is equal to?
Yes, that is correct. That is 10. Let us move on to our problem number 2. The number of citizens n of Malanday is predicted to increase and can be modeled by the function n of t equals 5t raised to 4 minus 3t raised to 3 plus 120t plus 18,000, where t represents time in years, and then if we are asked to find after 2 years, how many citizens will be residing in Malanday.
So the first task that we're gonna do is to understand the problem. And in this problem, we are given a polynomial function that models the population of Malanday. We are tasked to find the number of citizens after 2 years. Yes, that's mentioned there. And after 2 years, we're going to get the number of citizens there. And then after that, we're going to devise a plan. And we know that if we're going to substitute 2 as our time, because it was mentioned in the problem, into the function, and then we're going to simplify each term, then we're going to get the number of citizens after 2 years.
Now we're going to move on in utilizing our formula, which you can see here. Alright? So now we're going to substitute our time, which is equal to 2. N of 2 is equal to 5 times 2 raised to 4 minus 3 times 2 raised to 3 plus 120 times 2 plus 18,000. And then from there, we're going to evaluate this first, the ones who have exponent. So from there, we have 2 raised to 4 is equal to 16. And then 2 raised to 3, we have here 8. And then 120 times 2, we have 240. And then evaluating that, we have 5 times 16 is equal to 80. And then 3 times 8 is equal to 24. And then just bring down 240 and then 18,000. And then from there, we're going to apply the operations. So we have 80 minus 24 plus 240 plus 18,000. And then we will get, alright, that's correct. That is 18,296.
This example shows how real-life problems can be solved using polynomials and polynomial equations. By following George Polya's steps, we can solve problems in a clear, organized, and logical way. Remember, U stands for understand the problem. D stands for devise a plan. C stands for carrying out the plan. And L, always look back your answers. Now that you have seen how we solve real-life problems involving polynomials using George Polya's steps, it is time for you to try solving problems on your own. I have prepared 3 problems that you can try, and you can do screenshot or pause the video for you to try. Are you ready? Alright, answer item number 1. That's all for today. I hope you learned something from me. Till next time. Bye-bye!